Hello everyone! In the previous video we figured out which method and formulas we need to divide a parabolic shape into simple flat figures. So you can make your own solar concentrator using just cardboard, scissors, glue and reflective tape, of course. Now we want to build a web application that helps us calculate the concentrator with any parameters we choose. As you remember, we have three input parameters. First, the focal length. Second, the maximum aperture radius. Third, the size of the cookware. The focal length defines how far the cooking area will be from the center of paraboloid. Users of our application will be able to decide whether they want a more compact cooking device or a more convenient design with a space between the concentrator and the cookware, for example, to allow for transparent thermal insulation. By the way, it's very important to retain solar heat at the cooking area. The maximum aperture radius defines how much solar energy we want to concentrate, and also how much space the concentrator will occupy. The cookware size is self-explanatory, it's the size of cookware. To implement the web application, I decided to use the ReactJS framework because I want to understand how it works. It's the most popular front-end framework and I need to know how to use it. Previously I used the Vue.js framework in my projects. Second, we will have both the calculation and the presentation layers in one place, the web browser. At this stage there is no need to save any user's data, so we can create a simple one-page app. Third, it's very easy to show and share this app. Let's create a new application using Expo. It allows us to create an application that can run on Android and iOS devices as well as in a web browser on a regular laptop. Let's choose the latest version of Node.js using NVM, Node Version Manager. Start the created app and you will see something like this. Look at this screen. Here you can see the structure of the project. Let's create a new folder for our components. Now let's create our first component where the user can enter the input parameters. Here I use the useState hook to hold input values between re-renders. It's all about ReactJS. Maybe we will use it somewhere else. Next, let's create a component for displaying the calculation results. In both components I use simple HTML tags, but in the future I may need to use special tags from React Native, which you can see in the index.tsx file. The rows of the results table are rendered by an additional component. Now we need to pass the input data from the child component input data to the parent component home screen. We'll use props to pass the parent's method to the child component. The user will call this method when pressing the send button. The method will be called with the necessary parameters and saved to the parent state. After saving, we can call the function to calculate the number and dimensions of the flat trapezoids. Let's create a folder for the calculation scripts and name it utils. create a new file and name it unwrapper.tsx. Here we'll write two functions, one to calculate the heights of the trapezoids and one for the bases. There will also be a function to determine the division steps. In the getListTrapezoids function, we first calculate the rounded number of sectors. This means the width of the largest trapezoids may not be exactly equal to the size of the cookware. By the way, the number of layers is also rounded. That's why the resulting paraboloid can end up with a slightly smaller radius. As a result, we get two arrays and one number representing the number of trapezoids. The first array is a list of trapezoids heights, and the second is a list of trapezoids bases. Let's pass all of these results along with some input parameters to the unwrapper results component and display a table of the results. Each row of the table is implemented in an additional component called row results TSX, which shows the parameter of the trapezoids at each level. Let's also create a new component specifically for drawing the shape of each trapezoid. Now let's show the input data component only when no input data has been provided. Once the user enters this data, we hide the first component and display only the second component, unwrapper results. So, this is a working prototype of a useful application. Yes, it looks a bit rough, but we can already use it to calculate any solar concentrator we want. Let's create a new GitHub repository and publish the project there. That way you can clone the repo and run it on your computer. Finally, let's run a linter on the project and build the web version. To publish the project on GitHub pages, we'll follow the instructions at react.dev/learn. Let's add the necessary JavaScript packages and adjust a few configuration files. After that, we run npm run deploy and our project is published to GitHub pages. Now you can try it out yourself. We've figured out the geometry of a paraboloid and now we've implemented that knowledge in real life. Wait, it's not real life yet, it's just a web application. We still need to cut out the part of paraboloid what we want, glue them together and see how it works in practice. 1 cup of boiling water will show us whether we did everything right or not. I hope I've inspired you to feel confident about creating your own projects in the field of energy efficiency, even building your own tools to support them. If you have any questions, I'd be happy to answer them in the comments below this video. And see you in the next video. Bye!